All right, now we're moving on to trick C. So trick C, again, can follow tricks A and B. Maybe you've already changed everything to sines and cosines. Maybe you've already looked for glaring identities and now you're stuck. And what you might be stuck with is two terms that you need to add together, but they are fractions. And that's where trick C comes into play. So when I look at this, my right-hand side is as simple as it's going to get. 2 sine x. My left-hand side, what you see is two terms where everything's in terms of sines and cosines. So what can I do? Well, there's a couple options with this one, but one of the options we need to do trick D for. So I'm only going to teach this one way, but I will say there's more than one way to peel this potato. What I'm going to look at here is that I have common denominators. I have a 1 minus sine x and I have a 1 plus sine x. So I'm going to create a common denominator of 1 minus sine x times 1 plus sine x. How am I going to do that? Well, I'm going to multiply this one by 1 plus sine x over 1 plus sine x to give me cos squared x times 1 plus sine x, and then minus cos squared x, and then this one I have to multiply by the 1 minus sine x over 1 minus sine x. So I get 1 minus sine x on the top. Okay, so now I've created a common denominator, and now I can try to get it into one term that will hopefully simplify to 2 sine x. Well, how am I going to get there? Let's see. Let's multiply the numerator through. I get cos squared x plus cos squared x sine x. Then I'm going to multiply the minus cos squared x through. So I get minus cos squared x plus cos squared x sine x. Now you'll notice I haven't written the denominator out yet because sometimes with identities you want to multiply the denominator through and sometimes you don't. So when I look at this one, if I went to the next line, I can see that I have a cos squared x minus cos squared x is gone, and then I'm going to have 2 cos squared x sine x's. So I'm thinking that if I keep this denominator in this factored form, this 1 minus sine x, 1 plus sine x, I'm going to be stuck here. So I'm going to multiply my denominator through as well. Again, I don't always, but sometimes I do. Because these are conjugate pairs, I'm going to get a difference of squares. So 1 times 1 is 1. Then I've got plus sine x minus sine x is gone. And then I have minus sine squared x. Then, looking at this next step, my numerator simplified to 2 cos squared x sine x, and I've got a 1 minus sine squared x in the denominator. I have a glaring identity. I'm going to replace 1 minus sine squared x with cos squared x, so that this one is going to be a cos squared x, and then I can simplify. Boom, boom, and I am left with 2 sine x. So again, this one had looking for glaring identities in it, and it had creating common denominators. There is a third way of solving this problem, but again, we need to learn another skill. I'll just say it though, if anybody sees cos squared x as 1 minus sine squared x, that's kind of the way to go, but then you have to factor which is coming up. All right, here's another one. Again, remember we've done tricks A, B, and now C. When I look at this question, I have a cos x over 1 minus sine x, and I have a minus tan x as equal to a secant x. The first thing I'm going to do is change everything into sines and cosines. So I'm going to change my right-hand side into 1 over cos x using my reciprocal identities. Then on the left-hand side, I'm going to change the tan x. So I've got cos x over 1 minus sine x minus sine x over cos x. Now you could do this by leaving it as tan x over 1 and then creating a common denominator, but trust me, it gets gross. So change the tan x into sine over cos x and then go from there. My common denominator is going to be cos x times 1 minus sine x. So I'm going to multiply this guy by 1 minus sine x. And I'm going to multiply this one by the cos x. So now I have a common denominator of cos x times 1 minus sine x. And in my numerator, I have a cos squared x, and then I'm going to multiply this one through. So minus sine x plus sine squared x. Now what? What do you notice? So let's think of our things. Change everything to sines and cosines. Done. Look for glaring identities and creating compound or creating common denominators, adding. I already did the common denominator, so let's think about glaring identities. Let's think about the fact that we have cos squared x plus sine squared x. That is going to simplify to 1 minus sine x over cos x times 1 minus sine x. And again, be very intentional about showing all of your steps. Even if you can see ahead that this is going to simplify, you have to show that you've replaced cos squared x plus sine squared x with 1, and now you can simplify. So I've got 1 minus sine x, simplifying with a 1 minus sine x, and I'm left with 1 over cos x. And so I'm good. Left side is equal to right side. All right, let's try one more. I just threw this one in here because it was a good one from the textbook where I was like, whoa. And I thought, hey, let's do it together. So for this one, step number 1, change everything into sines and cosines. And again, I shouldn't call it step number 1. It's just option number 1. That line is just awful. There's got to be a way. I wonder if I can. Oh, did I just find a way? Whoop. Probably shouldn't do this while I'm recording a video. Oh my goodness, I just drew a straight line. That was really exciting. Okay, so now what we're going to do is we're going to simplify. So we're going to simplify the right-hand side, and I'm going to change everything into sines and cosines. So this one's going to be sine. Oh, I'm forgetting the name of that symbol. Is that a sigma? No. Let me think about this one. So sine of something over cos of something plus, and then here we're going to have sine of t over cos of t. And then maybe I'm going to create a common denominator. Let's keep working with the right-hand side. So my denominator is going to be cos. Oh, this is bugging me. I don't know it. Give me a sec. All right, I Googled it. It's sigma. I was right. So where were we? So we're going to make our common denominator cos sigma, and then cos, I'm assuming that's a theta. So apparently in Greek you can use lots of different letters to represent this, or symbols to represent the same thing. And that one is apparently a tau. So our common denominator is going to be cos sigma cos tau. So what do I have to do? Well, I have to multiply this guy by cos sigma over cos sigma. They're really hard to draw. And then this one I'm going to multiply by cos tau over cos tau. So my numerator for over here is going to be sine sigma cos tau plus sine tau cos sigma, which is making me feel like I want to go to here. So I was going to take this one and expand it out as a sum and difference identity, but I kind of just want to make this smaller. So you can expand this guy out, or you could recognize that on the right-hand side, in my numerator, I have a pattern. Cos sine, or sorry, sine cos, cos sine. So you have to kind of think of these in a different order, because it didn't matter which way I wrote them when I multiplied them. So the way the identity goes is that's the sine of the first angle times the cos of the second plus the cos of the first angle times the sine of the second. So I'm going to replace this as a sine sum and difference identity. Sine, you always match the sign. And then I would have sine of sigma plus tau, and my left side is equal to my right side. And again, you could have worked with the left-hand side or the right-hand side, but I chose just to work with my right. All right,